Okay, vertex form of the equation of a quadratic function, right? So there is a form of the equation of a quadratic where we can read the vertex, right? And we get the direction of opening because which letter affects the direction of opening? And we're looking at A. Okay, so ax squared plus bx plus c is the standard form. The vertex form is also going to have an a, and it's the same a. It does the same thing, right? Positive opens up, negative opens down. If a is greater than 0, then you're getting a stretch up, you're getting a narrower quadratic. If a is between 0 and 1, you're getting a wider quadratic, positive up, negative down. So we've found 5 methods we use to graph. We can use the graphing calculator or decimals, which is available for the iPad and iPhone. So if you have one of those, it's kind of a nice thing. You can use a table of values. So from a table of values, we know the shape we're graphing, right? It's quadratic. So we use table of values. We see the points. We can sketch it. We can use the equation in the form y equals ax squared plus bx plus c, but all that really tells us is direction of opening, also how it's stretched, right? Is it really narrow or is it wide? And the y-intercept. Using the equation in factored form, so this is factored form, referring to the r and s values. Really, there should be an a in front of here, I think, right? Because again, and that's the same a, right? A bracket x minus r. That a is the same as this a. Does the same thing, direction of opening and vertical stretch. We can find the intercepts. If we know the x-intercepts, we know that halfway we average them. Halfway in between is the axis of symmetry. The axis of symmetry is a line. It has an equation x equals, right? We get that. We plug in that x value into whichever form gives us the y value. We then have the coordinates of the vertex. And if it doesn't factor, we can use partial factoring, as we did yesterday, where we just take the first two terms, factor out whatever's in front of the x. If it's negative 2x squared, we factor out a negative 2. If it's 1/3 x squared, we factor out a 1/3 x. And again, then we find 2 points on a horizontal line, right? In this case, the horizontal line is the x-axis. In this case, it's just a horizontal line. And then we follow the same procedure, right? We get the x-coordinates of the points on a horizontal line, average them, gives us the axis of symmetry. We know the vertex lies on the axis of symmetry. We take that x value, et cetera, et cetera. Now we will learn the last method. It was not on that page. The vertex form of the equation for a quadratic function. So there's one more form, and this is what it looks like. And its vertex form means, looking at this, we can read the vertex, right? We can just look at that equation, say the vertex is at, boom, and give the coordinates. But before we get there, which way does this thing open? It opens up. How do we know? Because the a value, which is the number in front, is positive. Where's the vertex? Okay, so from this form, the vertex, well, we got this x minus 3, so the vertex is at 3, right? Because we want to make that as 0. So we put a 3 in there. 3 minus 3 is 0 squared 2, and gives you negative 4. Okay, so the vertex is at 3, negative 4. The axis of symmetry runs through the vertex, right? So it's x equals 3. You basically kind of want to make this expression here equal to 0, right? You make it equal to 0, that's where the vertex lies. Okay? Because it's the biggest point or the smallest point, right? In this case, this opens up, and its lowest point is at negative 4. Right? Because any number I put in here other than 3 is going to be a bigger number, and then that's going to change this guy, right? We'll be above negative 4 because we open up. 2 points on the graph. So if we want to get 2 points on the graph, we can let x equal 0. We can just say, all right, what's the y-intercept? Okay, now in this case, y-intercept is not negative 4, right? That's in standard form. So 2 points on the graph. Let x equal 0. Okay, it's going to give me y is equal to 2. 0 minus 3 squared minus 4, which is 2. Negative 3 squared is 9. Minus 4 18 minus 4, which is 14. Okay, so we got a point at 0, 14. Okay, that's a useful point, right? So putting in x equals 0 gives us a useful point because that's the y-intercept. If we want to graph, it's always nice to, hey, there's the y-intercept, right? I can graph the y-intercept. By symmetry, right, the axis of symmetry is at 3, so if we have a point, so here's the axis of symmetry at 3, and over here we've got 0, 14, then what's on the other side? What's at the same level but over here? So 0, 3. Think about a sketch, right? So there's 3. We have 0, 14. Then what gives us a 14 over here? 3, 0, 6. Okay, so by symmetry, another point is 6, 14. Okay, so we're always going to look for, we'll make x equal to 0, right? It's easy to find the value, and you're just squaring the number in there. Negative 3 squared is 9, times 2 is 18, minus 4 is 14, and then we'll go with symmetry, which is, okay, I found a point which is 3 units away, right? 3 units to the left of the axis of symmetry, so there must be a point 3 units to the right of the axis of symmetry on this same level. And sketch the graph. Oh, I already did that. Well, let's re-sketch the graph. Okay, so let's label some things here, right? We got x equals 3. We've got the point 0, 14. We've got the point over here by symmetry of 6, 14. We don't know what the x-intercepts are, right? But we do know that the vertex is at 3, so it's on this line, 3, negative 4. And we've got 3 points, which is really enough to give us a decent sketch, right? Because we've got the vertex, and then we've got 2 other points. They're symmetrical. We know the direction of opening, right? So we know how we have to draw this. And really, without knowing the direction of opening, it would still have to open up. If that's the vertex and then there's 2 points there, you can only draw it opening up, right? Okay, questions? So we'll do a few more, right? So you just need to see a bunch, and then you go, okay, yeah, makes sense. All right, hang on. So I'll leave this so we can see. Which way does this open? Down. Does that really matter when we go to sketch it? Not if we know the vertex and 2 points, right? Because the direction of opening will be obvious from the information that we have. But it opens down. Where is the vertex? Not 2. Negative 2. And 6. So when you're thinking about why is that the vertex, right? So we know it opens down, which means that it has a maximum value of 6, right? Well, how are you going to get to that maximum value of 6? Or I'm telling you the maximum value of 6. You might not believe me now. Couldn't you put another number in there and get something bigger than 6? Well, think of it this way. Whatever number is squared, right, we're going to take x, add 2 to it, and square it. That's going to give us a positive value, right? Then we're going to make that negative, and then we're going to add 6. So if you think about what's the largest value I can get, well, if I'm going to take a number and make it negative and add 6, the largest value I can get is if that number is 0, right? Because then I got negative 0 plus 6, which is 6. Any other value for x, like you make x 0, you get, which we do need, right? Because we want that for a graph. So let's do this. We make x 0. 0 plus 2 is 2. Squared is 4. Then this makes it negative 4 plus 6, which is positive 2, right? So let x equal 0, and we get 0, 2. I'm not going to show the full deep, right? I mean, you can do the substitution yourself. And we've got an example up there where it's substituted. Okay, so if you need to show the work, go ahead. But you make x 0. 0 plus 2 is 2. Squared is 4. Minus 4 plus 6 gives me positive 2. Okay, so if you think about any value, now here, look at this one again, we'll go back to this guy. We know that it opens up, this is a minimum, okay, so I'm subtracting 4. What's going to give me the largest value? Well, if I make this 0, 0 minus 4 will give me the smallest possible value, right? Any other number in here, if that's a 4, I'm just going to get a 0 out, right? So in order to get the maximum or minimum, this is actually the value, right, of the maximum or minimum. It's a minimum at -4 when? When x is 3, why? Because it makes that 0, and that's what's going to give me the minimum. And here, to get the maximum, since that's negative, I need this to be 0, so I'm not doing anything other than adding 6. Yep.
Can you explain how that's 2 again?
So you want to get a value, it's -2. It's not 2.
No,
Oh, why? This
0
is 2.
and 2, yeah.
Okay, put x as 0 in there. What's 0 plus 2?
0 plus 2.
2. Square that.
4.
Make it negative.
-4.
Add 6.
Okay.
That's where you're at. Okay. Okay, axis of symmetry is x equals. Yeah, somebody's got to say it. Right? Where does the axis of symmetry passes through the vertex, right? So, you know, up till now, like yesterday we were doing, where's the axis of symmetry? Give me 2 points on a horizontal line. Let me average them. I'll get the axis of symmetry. Okay, what about it? Well, I know that the vertex lies on the axis of symmetry. So when the axis of symmetry says x equals -2, then I know that the vertex is at -2, and I substitute that in and work it out and get the other value. Here, from vertex form, we get the vertex. Now you look at it and say, but the axis of symmetry goes through the x-coordinate of the vertex. So if I give you the vertex, you get the axis of symmetry. Yesterday we would go from axis of symmetry to get this, plug that into the equation, and get the y value. What's another point then that has the same value? It's on a horizontal line. Okay, so we're at 0. That's 2 units to the right of -2, so we need to go 2 units to the left of -2. And somebody said it. What was it? -4. Okay, let's sketch that. And, you know, when we go to sketch, let's forget this -4 for a moment, right? Let's just say, all right, look, what do we know? I've got x equals -2. There's my axis of symmetry. When x was 0, I've got 2, so there's the point 0, 2. My vertex is at -2, 6, so there's -2, 6. This has to open down, right, because that's the vertex and there's a point, so this has to open down, right? And we know it does because of the negative, but we know it opens down because we got these 2 points here. There's your vertex. Well, if that's my lowest point, I can't go up to reach this, right? So it has to be my highest point. And then you go here and you say, all right, look, it's 2 units, so I got to go 2 units over here. There's -4, 2. So by symmetry, they have to be on that horizontal line. Right. Does that make sense? Okay, so it doesn't make a great amount of sense yet. You're going to have to do a bunch of these, right? You have to look at vertex form and just keep working with it. And if you like, start off by graphing it just so you can see it. So I want to see that first, and then, you know, you might start to put it together. Okay, -3x squared plus 2. Now this could be written x plus 0 squared, right? Because what we really want to do is say, you know, if there's brackets there, this is really telling us where it's moving, right? This says, well, you got to put a -2 in there. So this says, what does x have to be to make this whole thing 0? Just 0, right? So it's not moving. And you notice there's no b value. Remember the b value? So when we first looked at these, what does the a value do? It changes the shape and the direction of opening, right? We played with the a slider. We played with the b slider, and it started moving it to the left and to the right. If there's no b value, then it's not moved left or right, right? It stays where it is. So the vertex is at, okay, wait, which way does this open? Down. Where's the vertex? 0, 2, right? Okay. We kind of knew that from like day 1, right? If we just played with the a and the c, we would have said, oh, well, excuse me, -3 is going to make it narrower and open down, and then that +2 is just going to move it up 2. Axis of symmetry is x equals 0, right? These guys match. Axis of symmetry, remember, it's an equation. So if I say what's the equation axis of symmetry, don't write 0. You write x equals 0, right? It's a line. It's a vertical line. By symmetry, what are 2 points? So we can say, oh, well, we've got the vertex. If I put x equals 0 in there, well, I've already found that. So we're just going to need to pick another point, right? So pick a number, any number. 5? Okay, what's 5 squared? 25 times negative 3 plus 2. Negative 73, right? You went the wrong way. That's going to be tough to graph, right? Like, I don't want to graph that, so, you know. Well, we already did. Let's make x 1. Okay, we'll move 1 unit. Okay, what's 1 squared? Times negative 3 plus 2. Negative 1. What's the other point then? All right, I don't see any answers, so I'm going to sort of draw what I have. It goes through 0, 2. It opens down. It goes through 1, negative 1. And then it goes here. So what's another point on this horizontal line? Negative 1, right? Yeah. Okay. Why? Well, I mean, if from the, this is the axis of symmetry, right? Here's the axis of symmetry, x is 0. So if I go 1 unit this way and get to negative 1, then I have to go 1 unit this way and get to negative 1, right? Because it's symmetrical, right? Here, we moved 2 units this way, so we had to go 2 units this way. Okay, why don't you try this? I will pause. Okay, so here's the answer to this line. A is positive, right? 1/2, it opens up. That makes it actually wider. That's kind of a lousy drawing then, because, you know, the 1/2 should have made it kind of wider. But that's just my scaling. The vertex is at negative 4, right? The value that makes this 0. So negative 4, negative 3. The axis of symmetry, right? These guys just match. And you write it as x equals because it's a line. When I put x as 0, 0 plus 4 is 4, squared is 16, half of that is 8. 8 minus 3 is 5. I get the point 0, 5. I draw this out. I've got my axis of symmetry. Here's my vertex. Here's 0, 5. That's 4 units to the right. I need to go 4 units to the left. 4 units left of negative 4 is negative 8. Okay, questions? In general, if the equation of a quadratic function is of the form y equals a, x minus h squared, comma k, hk is the vertex of the function. H is the value that follows a minus sign, right? So if you see x minus 3, 3 is the x-coordinate of the vertex. If you see x plus 3, then you have to think, well, how do I write that as x minus? Okay, so if I had like y equals negative 2x plus 3 squared plus 5, I would never write this. I just did, but I would never do that, right? But you say, okay, this I need a value after the minus sign, but this is a plus, so I could write that as minus negative 3. So when I'm thinking about where's the vertex here, it's at 3, negative 3, right? Negative 3, comma 5. So h being the value following a minus sign. It's real easy, right? When you look at this, just change the sign. If that's x plus 3, you write negative 3. If it's x minus 3, you write positive 3. Okay, hk. X equals h is the equation in the axis of symmetry. So for this guy, x equals negative 3. If a is less than 0, it opens down. This is less than 0, it opens down. If a is greater than 0, it opens up. Questions? That's just summarizing what we've just done. Determining the vertex form of the equation of a quadratic function. to find the vertex form of the equation, so y equals a bracket x minus h quantity squared plus k, or, f of x equals, right? So it could be an f of x or it could be a y. All that's saying is just vertex form. This is expressed as a function, and this is just y equals. Okay. What do? We locate the vertex. So given in this form, we locate the vertex to find the values for h and k. So in other words, if I give you a graph, can you give me the equation, right? And you say, all right, I'm going to find the vertex. That gives me h and k. I'm going to locate a nice point. So on a test, we'll like put a big black dot somewhere, right? You can see. So you get the coordinates of that point. We substitute the nice point into the equation for our x value and our y value. Okay, so we know h and k from the vertex. We find a nice point, that's x and y. The only thing we don't know is a. So using everything we've got, we can solve for a. Okay, so that's substitute the nice, solve for a, rewrite the equation using x and y now, not the nice point, but going back to x and y, or f of x and x, and put in the value of a. All right, so let's do it. Determine the equation in the form. So first step, get the point, coordinates of the vertex, right? Which are 2, 4. Locate a nice point. Here is a nice point. 1, 1. Here's another nice point if you want to use this point. 3, 1. So a nice point basically just where is the curve going through a grid intersection? So where can I need a point where I know the x and the y value. Okay, and what do? So let's start off with the formula. Okay, so that's the vertex form. We're going to start off by writing it down because that just communicates to whoever's looking at this, look, I know I'm finding vertex form. Here's the formula for vertex form. I'm going to substitute in my value for h. Okay, h is positive 2, so it's x minus 2, and k is positive 4. Okay, so remember it's x minus h. H is a positive number. H is 2, so you go x minus 2. We then go and we say, okay, that's part of the puzzle. Let's put in this 3 and 1. Okay, so y is 1 when x is 3. Okay, so we found the vertex, we put in the values of h and k. Now we found the nice point. The nice point is x equals 3, y equals 1. X equals 3, y equals 1. We're now going to solve for a. Extend page. So we've got 1 is equal to a. 3 minus 2 is 1. Squared plus 4, right? So 1 is equal to a plus 4, and a will equal negative 3. I'm going to subtract 4 from both sides and get a equals negative 3. Okay, so I'll just move this over here, subtract, get negative 3 equals a, and then just flip sides, so I write a equals negative 3. Okay, so if you want, you could have this step in here, negative 3 equals a, and then let's just say here's what a is. Now we go back to this line, and we put in the value for a. So we go y equals negative 3 x minus 2 squared plus 4. Okay, you don't put a parenthesis there. Yep.
So how did you get a equals
Subtracted 4 from both sides, right? 1 minus 4 is negative 3. Okay. So I need to get the a by, so 1 squared is just 1, right? That's a. So I got 8 times 1, or just a, plus 4, so now we subtract 4 from both sides. Gives me negative 3 equals a. You can write that if you want, or you can just go straight to a equals negative 3. Right? We're just saying, what's a? So think about it. If I gave you this, then what would you tell me? You'd say, it opens down. There's some vertical stretch, right? It should be narrower than the regular x squared, but whatever. The vertex is at positive 2, 4, right? So just forget the graph. Look at this and just say it opens down, the vertex is at 2, 4. It opens down, the vertex is at 2, 4, and it is narrower, right? Here's another way to get the A value. Normally, if I move 1 unit this way, how far should I be going? Down 1, right? But I'm going down 1, 2, 3. That's really my A value, right? So if I move 1 unit here, however many units you move this way or up, right? Like from here, I go here, that looks like it's about a half. I think the A value here might be a half. It's harder to tell when it's this. Like I would guess A is positive 1/2 here. Now, how can I check that? If I go over 2 units, normally how far up would I go?
2 units.
Nope, 2 squared. Right? If I go 1 unit, I should be going up 1. If I go over 2 units, I should be going up 4, but we are going up 2. That's half of 4. That tells me A is a half, right? I know A is 1/2 from the graph, but I have to show you algebraically that A is a half, right? So we're going to solve for it, but we already know its value. And you could do the same thing here. You have to solve for it, but that's 1, 2, 3. You know it's -3. It opens down, and this should be over 1, down 1, but it's over 1, down 3. Looking at the graph, you should say, I know A is -3, but I have to show it, right? So when I solve it and get A is -3, I'm not surprised. It verifies what I'm thinking, right? Here, I'm thinking, what's A, right? Well, go over 1 up. That looks like a half. Go over 2, should be 4, but it's only 2, so that is 1/2, right? It's positive 1/2. Okay? But we have to do this right. So where's the vertex here? It's at -5, -3. Okay, let's write down the formula, right? Remember, we're aiming for vertex form. Vertex form is y equals a, x minus h, quantity squared plus k. Right? So let's write it down. That if somebody else looking at your solution, they can look at it and say, oh, okay, you wrote down the vertex form. And then you're going to substitute in your value for h and k. So what goes in here? Plus 5 or minus 5? Plus 5, right? Okay, because we have to go x minus -5, right? X minus negative is that's plus. Right? When you subtract the negative, you add a positive. So we get x plus 5 squared. Think about what this means too, right? It means the axis of symmetry, looking at this, we just say, oh, I got to change that sign, right? It should be x equals -5. Oh yeah, right? That matches. Now we need a nice point. Well, here's a nice point. -3, -1, right? Or here's a nice point. -7, -1. I don't think there are any other nice points on that graph. So to get a nice point, we would have to go 4 units and up 16, which would then be half, which would be 8, but our grid's not big enough to show that. Okay? So, substitute in the nice point. Which one do you like, -7 or -3? -3. So -1 is equal to a, -3 plus 5 squared minus 3. -3 is nice here. Why? Because it makes this positive, and then you don't have to worry about messing up the squaring by improperly squaring a negative, right? So here we get +2. You put -7 in, you get -2. Whether you square 2 or -2, you're going to get +4. Okay?
Why do we put -1 into it? -1?
Nice point.
Okay.
Nice point x value is -3.
Oh, and y.
Nice point y value, y, -1. Okay. So it's not always, it's whatever the coordinates of the point are.
Okay.
So -1 is equal to a. -3 plus 5 is 2 squared minus 3. -1 is 4a minus 3. Right, so we're just squaring the 2. If you put a -7 in there, -7 plus 5 would be -2 in brackets. When you square -2, what do you get? +4. Okay, so either way. What do I do with that -3 then?
Isn't it positive? Because,
That's negative, negative.
Add 3 to both sides.
So we're going to move it to the other side. We're going to add 3 to both sides. What's that going to give me? 2 is equal to 4a. 2 over 4 is equal to a. A is 1/2. Oh my God, that's a shock. We already knew that, right? So you're going to be able to, most of the time, count it out and figure out the value of a, unless it's something like 1/3, 1/5 or something. Right? There's no way you could count, no way you could really see that off the graph very easily. Okay? Unless we went out 5 and it should be up 25 and it's only up 5, and then you go, I don't know. should be 5/25 versus 5/5, that's 1/5, right? So we knew that A was a half. And so now we write our final answer. So y equals, so we go back to y, right? We're going back to this line, right? Because it's y equals, it's got to be an equation. Y equals, but now we have the A value, 1/2 x plus 5 squared minus 3. So forget everything that's above this line. Look at this, and you say, my vertex is at -5, right? Got to change the sign here. So when I look at these guys, I just say, just change the sign, right? So it's at -5, -3, opens up, and it's a little bit wider than, it's a -5, -3, it opens up, and it's a little bit wider. Okay? So your check is just to match up what you wrote, right? Because you wrote the vertex form, and then say, forget there's a graph there. Where's the vertex? -5, -3. Go back and look at the graph. Say, yeah, that's right. It is at -5, -3. It's positive 1/2. That means it opens up, and it means that it's wider. How much wider? Well, again, if I move 1 unit, I should only be going up 1/2 instead of 1. And if I go 2 units, I'll be going up 1/2 of 4, which is 2. If I go 3 units, I should be going 1/2 of 3, which is 4.5. 1, 2, 3, 4 and 1/2. And if I went 4 units, I'd normally be going up 16. I should be going up 8. We can't see it on this grid, right? But if we had more of the graph on there, you could see that going up over 4, you'd only go up 8. And that's going 1 either direction, right? Go 1 to the left, you still go 1/2 because you're squaring. Go 2, 1/2 of 4 is 2, right? Okay? Next. Okay, so now we're going to get away from the fact that we give you graphs and we're going to give you words. A coin is tossed into the air from a height of 3 feet and reaches a maximum height of 7 feet 2 seconds later. Determine an equation in vertex form for the height of the coin as a function of time. So what's the first thing I'm going to do?
Draw a graph.
Draw a graph, yeah. Draw a sketch, right? I need to know what's going on here. And when I draw it, I just want to label it. So I want to put my information into a visual form. That's the way I work. You don't necessarily have to work that way, but I want to see what's going on here. So I know that if I toss a coin, okay, so let's draw this. Function of time, right? So this is going to be time, and this is going to be height. Okay, so instead of x and y, we've got function of time. Height as a function of time, that is y as a function of x, right? Remember f of x, function of x. Okay, it's tossed from a height of 3 feet. So at time 0, it started out at 3 feet, and it's going to do this, right? So at a time of 0, it's 3 feet high. What are the coordinates of this point, which happens to be the vertex?
7, 2. 2, 7.
Yeah. Oh, I was going to ask what happened to him. You're here. Didn't know if you got injured or well, you are injured. Did you play?
Yeah.
Do you think? No, because I wouldn't have. So now is it like totally wrecked?
Pretty much.
Now you're out for how long?
Till Friday.
Oh, until Friday when I'm going to play again. It's okay, I can have surgery at the end of the season.
Exactly.
You realize at some point this
You can do it
season,
later.
you're just going to be, you're going to be sitting on the sidelines tweeting the results of the game, I think. All right. Okay. What position do you play? 'Cause
Linebacker.
linebacker. Tough to do one arm, right?
Probably.
Well, if he doesn't now, he will by the end of the season. Okay, anyways, does that match the situation? Is that what we got? Yeah? So at time 0, the coin, because the coin starts out at 3 feet, right? I flip the coin. 2 seconds later, it reaches its maximum height of 7. What's a vertex, right? It's a maximum or a minimum. Okay, what have we got? We got the vertex, we got a nice point. We know what to do with that, right? So determine an equation in vertex form. So let's start off with vertex formula. Y equals A, x minus h, quantity squared plus k. We're going to substitute in the vertex, right? Because we know it. So y equals A, x minus 2 squared, right? Because h is h, right? If h were negative, it'd be minus a negative, that'd be plus. Plus 7. We have a nice point at 0, 3. Remember, x is 0, y is 3, right? I mean, it's tough because you're seeing 0, 3. You want to write 0, 3, but it's this way. 3 is equal to a 0 minus 2 squared plus 7. Okay, do the next two lines. Solve this. Are you right-handed?
Yeah.
Okay. You can still write. Don't worry about these. I didn't know if you saved online, so I'm turn them off. And whatever you missed, it's in the recording, we're 35 minutes. Okay, so I want you to go solve for A, and then write out your final form, right? So you're gonna write y is equal to, I don't know what A is, but this will be so there's our answer. You gotta get there.
How can we get 3? Yeah, why 2, 7?
If I put this in there, I'm gonna end up with 0 equals 0.
Yeah.
Which, while it's true, isn't helpful, right?
Yeah.
0 equals 0. Hey, that's true, but it's kind of useless. Right? So we're going to use the vertex, right? And then we're going to use a nice point, which can't be the vertex.
Yeah.
Because if it is, we won't solve for A. How do I know it's negative? Parabola opens down, right? So that's a check. If you solve this, you get a positive value for A, and you look at your diagram and you go, something's wrong. I'm saying it opens up. It opens down. So I must have made a mistake, and then you learn, oh, and you get your signs fixed up. Okay? Is that what y'all got? Yeah? Or no, I'm totally lost. State the domain and range for the function in context to the situation. Oh, it's the exact question asked in 30-2s, which is the exact question that you're going to get asked in 30-2 on the diploma exam. And what it says is, given a context for a situation, be able to state the domain and the range. Okay. So what's going on here? What makes sense? So I think what we need to do is, we need to say, when does the coin hit the ground, right? Because our domain is the x values or the time, and we need to know what time does this thing hit the ground. So how are we going to figure that out? How are we going to figure out what time this hits the ground? So we know it starts at time 0, right? Because time starts, there's no negative time. So we know for sure time has to be between 0 and something, right? That's 0, what's that something? How would we figure that out? Oh, you know what? This really here, this should be an H and this should be a T. That should kind of be H's and T's here, but I think it's okay here to work in X and Y, right? And then just at the end, just sort of translate and say, oh, really, that's an H, that's a T. How high is this?
0.
0. So what do I want to do to this? Put H as 0 in, right? And then figure out what T is. Okay. So given this equation, it'd be nicer if it was in factored form, but we don't have that, right? It's not, so, but we know, okay, look, so what's the context? Well, when H is equal to 0, what is T? That's part of what this says, right? What's our range? You can do the range right now. What's the range? 0 to 7, right? Coin can't be any lower than 0. I mean, could we flipped it out the window and we said the floor was at 0? You could, right? But again, that's a different context to the situation, right? If we were flipping it out the window, we'd probably make the ground 0, and then it would start off, instead of flipping it 3 feet, it would be like, whatever, 30 feet or something, right? It would hit a maximum of 37 feet and then fall to the ground. Okay, so here's what we're going to do. 0 is equal to -1 t minus 2 squared plus 7. We got to solve that. So here's what we're going to do. we're going to get rid of the 7 first. We're going to move it over. Negative 7 is equal to negative 1 times t minus 2 squared. Positive 7. So I'm just going to multiply. I'm going to divide by negative 1, right? To get rid of this. I need to get rid of this negative. I can divide by negative 1, or I can multiply by negative 1, right? Negative 1 times negative 1 is, I need to make that positive 1. Okay, so multiply both sides by negative 1, that'll work. Okay, or divide both sides by negative 1. So we get 7 is equal to t minus 2 squared. How do I unsquare something? Square root. So the square root of 7 is equal to t minus 2, so we're going to need a calculator. We're going to work out what's the square root of 7. Anyone? Square root of 7? 2.645. So let's call it 2.65, right? If in doubt or whatever, we'll round to the nearest hundredth. Okay, so 2.65 is equal to t minus 2. Now, really, this is plus or minus. But in this case, we don't really care about the negative, right? Because this thing also has an x-intercept over here. We don't care about that, right? So in context, we don't care if it's plus or minus. We're only interested in the plus one. But without the context, if I had just given you these numbers and said there's a parabola that's drawn that goes through 0, 3 and hits 2, 2, 7, what's its equation, or what are the x-intercepts, you'd have to do the plus and the minus, right? You have to realize there's two of them. But for our context, for us, only use 2.65. So t is equal to, so we're going to add 2 to both sides. It'll be 4.65. All right, now we're ready to do our domain. So what's our domain? Okay, domain is the set of all t's such that, now again, remember, I'll let you get away with just writing the next part, but I'm writing the full thing here. So t goes from 0 up to 4.65. So 0 is less than or equal to t, which is less than or equal to 4.65. And that's what we're interested in, right? You can write just that part. Right. So as for domain, you could just say t is basically, in English what that says is t is between 0 and the time is between 0 and 4.65. Okay. In math, we always write, when we're doing in between stuff, we always write it as lower number is less than or equal to the variable is less than or equal to the higher number. And range, we already said what the range was, right? What's the range? So, okay, height goes from 0 to 7, right? Doesn't start at 0, it starts at 3, right? Somebody's sitting there with the coin in their hand, they're flipping the coin, 3 feet, goes up to 7 feet, comes down, hits the ground. That's that height of 0. Determine. What does determine mean? It actually means show your work. It is solve, but it's actually show work, right? If I said state, what does state mean? Just give me the answer, right? State just says, I don't need to see any work. However, let me give you a word of advice. Whatever you're doing that involves any calculation, even if it says state, show your work. If you're doing a multiple choice question and it's not just a knowledge thing, right, like saying, does this open up or down, look at it, get the equation and says, does it open up or down or left or right? You're not doing it where you're saying that opens up. But if you have to do something where you're doing a calculation on multiple choice, try and show it, okay? Because if you get it wrong, we can look at it and say, oh, okay, see that should have been a minus, you put a plus. Because you want to know why you got it wrong. Getting it wrong is fine. Knowing why you got it wrong is a lot better because you can avoid making that same mistake. Not knowing why you got it wrong is just useless. I mean, you've not only lost the mark, but you have no idea how to fix whatever it is that you had going on. Okay, so show work. Anyway, determine, show your work. So you got a couple things you could do. You could graph this, right? You could go y equals -1 bracket x minus 2 bracket squared plus 7. Set the window appropriately, graph, go second function calc, value x equals 2.5, and plug that in and get your number. So if it's at state, you can just do that. Determine. If it did not say algebraically determine. If it says algebraically determine, you're going to use this. That's what we're going to do now. Right? We are going to algebraically determine it. Determine means show work. You would just say, I graphed y1 equals -1 t minus 2 squared plus 7, and I put in an x value of 2.5. Okay, and that's good enough, right? Determine is just show your work, explain what you're doing. If it said state, you could do it with your graphing calculator, just write the answer. We're going to do this. So h is equal to -1 t minus 2 squared plus 7. H is equal to -1, 2.5 seconds, 2.5 minus 2 squared plus 7. Okay, so formula, substituting in, I know the time is 2.5 seconds. I want to work out the height. H is equal to -1. 2.5 minus 2 is 0.5. 0.5 squared is 0.25. And let's pick that up. H is equal to 6.75. And let's say the height of the coin is 6.75. Is that it? Done? Finished? One more thing. What's missing? Height of the coin is 6.75. Actually, it's feet, but feet. Okay, so you need units on there, right? How high is it going? 6.75, whatever the units are, in this case, feet. It'd be tough to toss a coin 3 meters in the air if you're standing on a ladder or something. Nobody's got a reach of 3 meters. Well, shouldn't say nobody. There are freakishly tall people who might have reach. Oh my, there's more. A golf ball is hit and follows a parabolic path that reaches a maximum height of 65 yards and first hits the ground 118 yards from where it was first hit. Determine an equation in vertex form for the vertical height of the golf ball as a function of time. Basically kind of the same question, right? So what are we going to do first? What's the first thing we're going to do? Draw a diagram, right? Draw a picture. Label the picture with all the information that you can. Okay, that's time, that's height. Golf balls hit. Golf balls generally start off on the ground, right? So it starts off on the ground, goes up in the air, and lands back on the ground. And this is the t-axis. Does it say how long it took? No. So we've got question mark, comma, and it hit the ground at 118 yards. It reaches maximum height as a function of time. At some time after it was hit, it hit 65 yards. No, sorry, this will be 0. Right? So we've got 0, 0. Right? It's hit at time 0 and it has traveled no distance. We've got some time and 0 because it's back on the ground again, right? Its height will be 0. Hits the ground 118 yards from where it was hit. Determine equation as a function of that. And at some time it reaches a height of 65. That's an interesting question. What is that? Okay, we got to change this. Does yours say function of time or does yours say function of distance? Yours says time? We can't do it with time. So we have to do this as distance. Right? There's no information to do this. Look at what we've got. I have a partial vertex and I have no nice points. Right? I've got 0, 0, but I've got too many unknowns. Right? I don't know enough. So instead, we're going to say, all right, as a function, let's call that d. So I do know that in this time it traveled 118 yards, right? So it starts out at 0 yards high, 0 yards distance traveled and 0 yards high. It ends up as, well, wait a sec, this will be, no, 118.0, right? Let's get this right. So it's traveled 118 yards and it's at a height of 0 yards. Using pencils, right? Yeah, we got pencils out? Okay, so by symmetry, how far has it traveled when it hit 65 yards high? 100, when it's 118, it's back at 0, but it started out here. I have 2 points on a horizontal line. So where's this? 59, right? 0 plus 118, it's halfway, right? 59. See, in the other question, we didn't start out at 0. We didn't have symmetry in there going, right? We knew we started at 0, times 0 was 3 feet high. Okay, so I have the vertex. I have a nice point. So equation, y equals a, x minus h quantity squared plus k. Y equals a, x minus 59, right, at 59, squared plus 65. Let's plug in 0, 0 for x and y. You could also plug in 118, 0, right? But 0, 0 is nice. And now we can solve for a, right? So 0 minus 59 is negative 59, right? And then we're going to square that, which is going to give us, what's 59 squared? I think it's like 3481. Okay, so 0 equals 3481a plus 65. What do we know about a? Is it positive or negative? A value is going to be negative. Okay. How's that going to happen? Well, we got to subtract 65, right? So negative 65 is equal to 3,481a. So a is equal to negative 65 over 3,481. Now, probably doesn't reduce, but it might. If you want to know if that reduces, go in your calculator, go 65 divided by 3481, hit the math key, and go enter, enter. And it'll give it to you as a reduced fraction, which I'm willing to bet is 65 over 3,481. Does it reduce, or is it just 60? Yeah, so it doesn't reduce, right? Okay, so here's our equation, right? Distance and height. So we're using the height is equal to negative 65 over 3481 bracket, right? That's my A. And now I'm going to use height and distance in here, right? H and D. D minus 59 squared plus 65. Okay, so there's my, so I used x's and y's because that's what's on my formula sheet, those formulas I have. And then at the end I just said, oh, really it's height and distance, right? So height and distance. And that's more of a real world thing, right? Because you've got some kind of ugly number there, right? So it's not a nice, it's not like -2 or something nice like that, right? It's also a very small number, which means you get a very wide parabola. So if you think about the arc of that golf ball, it's not, you know, like you'd have to muff your shot and it would just go up in the air and land like 5 yards away or something, right? But just any golf ball you see traveling will always be a negative, and it'll always be some fraction, right? It'll always be way less than 1. State the domain and range for this function. So domain range we could have done right off this diagram. We don't need this. What's the domain and range? So the horizontal distance is from 0 to 118. And the range, the height goes from 0 to 65, right? Just make sure you're pulling the right numbers, right? Domain is x values, so it's the x, and range is y values, it's the y. Determine the height of the golf ball when it's 30 yards from when it was first hit. So we're going to go back into here, put a 30 in here for the distance. You're going to work it out because, well, I mean, I could, but you'll be faster. Okay, so what's the formula we're going to use here? So we want D equals 30. So we've got H is negative 65 over 3481. D minus 59 squared plus 65. And we want when D is 30, so we want H equals negative 65 over 3481. 30 minus 59 quantity squared plus 65. Okay, so I just want a number. And more than 3 or 4 of you should work it out so we can decide which of the 5 different numbers we get is the correct one. That's not true, we won't get 5, but we might get a couple of different numbers, right? And you always want to work this out, okay? Like on your own, on your calculator, without looking, just to check, right? So if you know, somebody says, oh, the answer is like 17, and you've got, oh, I got 72, and a whole bunch of people say it's 72, you know you did it right, but if you did this wrong, you have to know how to put that into your calculator correctly. Okay, so give it a shot, work it out. Let's compare. Now you know a few things, right? Based on this, you're looking at here. You know that it's got to be between 0 and 65. So if you get some negative number, you messed up. Okay? And if you get some number that's greater than 65, you messed up. Right? Okay, how high is it? 49.2. And that would be in yards, right?
Properly rounded up, it should be 49.3.
49.3. Okay, and again, you have to look at rounding, right? I mean, it didn't say, we should have said to the nearest tenth of a yard, to the nearest yard, to the nearest hundredth of a yard. Determine the 2 times that the golf ball is 20 yards above the ground. You can do this 2 different ways. We are not going to do the painful way, which would be doing it algebraically. We're going to do this graphically, right? You are not expected to solve this one algebraically, right? You're expected to be able to do this one graphically. So here's what we're going to do. Go in, turn this thing on, go to y equals. Okay, I got my equation. So I'm going to put it in. I like to put a bracket around it. So I'm going to go negative 65 divided by 3481, close bracket, right? So that's my a value. Bracket x minus 59 bracket squared plus 65. Okay, so that's what I'm going to put in, right? I'm going to go bracket negative 65 divided by 3481 bracket. There's a bracket x minus 59, close bracket squared plus 65. And we want it to be at a y value, a height of 20 yards above the ground. Okay, and we need a window, but we know our window, right? I mean, this goes from 0 to, I'm just going to say 120 for graphing instead of 118. And let's go by, say, tens. And this goes from 0 to, let's go to 70, because I go to 65, it's going to hit right up against the top, and I'd rather see a little bit more. And let's go by tens, hit graph. And so we should pretty much fill the window, right? That's the whole idea with calculators. You want to fill the window. You don't want to, you don't want to do this like zoom standard and say, what do I see? I mean, first of all, stuff that makes no sense. And then not much. Really, this looks like a straight line. If I graph, that's a straight line, right? You look at it and say, hey, that's the equation of a straight line. No, it's not. Right? 0. Okay, that's what it is. And then y2 is 20, right? So we're going to draw this. So there are 2 times. These are not times, they are distances. So determine the 2 horizontal distances. Somebody was confused when they wrote this question. What we're really determining is how far from the tee is the ball when it reaches a height of 20 yards on its way up, and then how far from the tee or the ground, how far from wherever it was shot is it when it's coming down and it reaches a height of 20 yards. Yep, yep. Okay, second calc, intersect. just move down to the first. Now, I'm going to show you an easy way to move, right? If I go along the curve, it's going to take a while. If I pop down to the straight line, then I can just move over to the point, right? Now, I've changed the first curve, but there's only 2 curves in there, right? So it's just enter, enter, enter. 9.9. Okay, so 9.9 yards. And, okay, same deal. Second count, intersect. Notice again, it's starting out, so if I start, I got to go up and around, right? If I just arrow down, go to the straight line, then I can just move along the straight line, as long as I do so for less than 3 seconds at a time. You don't have to lift your finger off every 3 seconds. I do. Cut it out. Okay, and 1, 2, 3. 108 yards. 108.1 yards. Okay, so when the ball has traveled a horizontal distance of 9.9 yards, it'll be 20 yards high. And when the ball is on its way down, it'll travel 108 yards from me, and it'll also be 20 yards high. Okay, any questions? Okay, so that's that. Look, in only 1 hour and 1 minute.